Okay, for this problem, first we have to do the factorize for the 34. And so first we have 34 equals to 2 multiply 17. And then we have this. And to summarize there, we have 2 squared multiply 70 squared. And then also same step for 63. It is just a step to minimize both of them. Okay, then we total have this letter n to be this. And we combine the prime factors together. We have this results. And then we know the sum of the divisors as so now we have the odd that is like this. Okay, and also for the sum of the odd divisors as and then we have to calculate all of it. So for the sum of the odd divisors as all, after we calculated is this, we have the 15. And also for this we have here like this one. Okay, and also for S even that we have the S all. We have this, so we know it. And then the ratio that is here. After the calculation, we have these answers. So this answer is, for the number 2 question, we know for a rectangle with the length is m and the width is n, we have the formula like the square tells the diagonal pass through is even by m plus n. We have this one. And here is the greatest common divisor. And for this one, m equals to 17 and n equals to 10. So now we have to calculate this one. And since 17 is a prime number and 17 does not divide 10, so this equals to 1. And now we use the formula that here. Okay, we substitute the numbers in it. That is, plus here equals to n. So the result is 26. Okay, for this question, first we have to know that the number is divisible by 3 if the sum of its digit is divisible by 3. So now we can know that none of the digits can be 3. And for the first case, like the hundreds digit here, it can be 1, 2, 4, 5, 6 here, and this. It cannot be 0 or 3. No. And for case 2, for the 10th digit, it can be 0, 1, 2, 4, 5, 6, 7, 8, or 9. And for this one, that cannot be 3. And for case 3, there must be odd. Cannot be 3. And we know for all of the choices, we have the total that is 8 multiply 9 and multiply 4. That is it. And now we know that each digit ABC that can be deserted by the mod 3. So that is 0, 1, and 2. Because we need to be like this. And this. The number of the only number that is. So the answer is 96. First, we can simplify this one. That is equals for here. And also for another part, we can substitute the factorials in this formula. That equals this one. And now we have to factor all the n from this numerator. And after canceling n and the numerator and the denominator, we get 2. And after this step, we factor out the n plus 1. We got this. And back to the answers that we choose D. That is a perfect square. Okay, firstly, that we suppose, for the sake of the contradiction, this formula is reducible. And then there exists a positive integer like d. Okay, such that d and by the property of divisibility, that if d divides two numbers, that we have d to a and b, and then d also divides any linear combination of a and b. Like, for example, here. And this is for any of the integral of j and k. So we want to find the j and k such that, like, j, something like that. It is simplified to the non-zero constant, like independent of n. So we can expand this formula to here, right? To expand this formula, and it can be and then we want to solve the system of the equations for j and k, like such as the coefficients of the n is 0. So it's like 21, this is 21, and here, or, so now we can choose the answer that, like, k is -2 and then j equals 3. And then we want to substitute j equals 3 and the k into the formula before, and then we can expand the right hand side that we have the, right? And then since d and the second one that we wrote before for here, and also but the only positive divisor of 1 is 1 itself, right? So we only have the 1 for itself, and then this contradicts our exception that d is bigger than 1, like we wrote before here, this one. So we have this formula that for every natural number n is irreducible. Okay, for this one, we know if here is divisible by n plus 10, and then when n equals to negative, we have this equals to 0. We can also use another one to divide this part by n plus 10. And by the long division, we have this, right? We have this one. And then if the second part is divisible by n plus 10, and then we know this part must divide to the remainder. Here the remainder is here negative, like the 900, so we need this one. And now we try to find the value of n. Let n plus 10 equals k. We know here k is a positive divisor of 900. Okay, I can write it here. Right, and since n also positive, so we know k is always bigger than 10, and we want to find the largest positive n, so we need to find the largest positive divisor k of 900, right? And so now let's find the positive divisors of here include 1, 2, 3, 4, 5, 6, and 9, 10, 12, 15. Okay, so on and to the end. So the largest positive divisor of k, the k of 900, it is 900 itself. And if k, okay, we know this formula, and then we can find the n value. The value of n is 890. Okay, so the largest positive here, this one, the answer is, for this question, that we know a number is divisible by 15 if and only if it is divisible by both 3 and 5. Okay, so we know that the divisibility by 5 rule, that is the last digit of the number must be either 0 or 5. And the last digit cannot be 0, because if the last digit is 0, there must be a digit before it, and that is less than 0, so which is impossible to be a positive the digit. So the last digit of the uphill divisible by 15 must be 5. And also for the 3 rule, the sum of the digits of the number must be divisible by 3. And then we can list all of the condition that is last digit 5. So when here is one digit number, that is the first case. And we know that only one digit uphill that will last digit 5 is 5. Okay, so that is 5 here, and the sum of its digits is 5. And 5 cannot be divisible by 3. And here for the 2-digit numbers, we know that we can let A be here, and that A be 1, 2, 3, 4, and the numbers are 15. The sum of the digits is like 1 plus 5 equals 6, and it is divisible by 3. And like 25, the first one, and second one, 25, that the sum of it is 2 plus 5 is 7. That is not divisible by 3. And also for the 35, and the sum, also the same condition as before, and the last is 45. It is divisible by 3. Okay, and for the 3-digit numbers, that was the last 5 are of the form like AB5, right? Now we know that the bigger and smaller conditions are like this, and the possible combinations of AB can be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. Okay, and that we are talking about for every combination of the words, that, like for example, 125, that the sum of the digits is 8, so it is not divisible by 3. And for everyone, we do the same time. Also for the 4-digit numbers, okay, that is the ABC 5 here. And also, this is the bigger and smaller one. And the only possible combination is 1, 2, 3, 1, 2, 4, and 1, 3, 4, and 2, 3, 4 here. And for the 5, also that is ABCD5. Okay, and the only one is here. And also we talk about the same idea for the 6-digit and more. Okay, for this one, actually we do need to consider the numbers with 6 or more digits. So now we know that all of the combination of course, you can calculate all of the combination for every sum of the digits and to see whether it is divisible by 3. And then we got the last answer is here. Okay, this is the second one. And here is the third one, fourth one, fifth one, and this. So let's count 1, 2, 3, 4, 5, 6. Okay, let's find the number of the ordered pairs A, B of the positive that satisfied the above condition. And so now we let D then we can write here, and we're for this one. And since okay, because we know that, and substitute it into the original equation, and then we have and simplified it. And then rearrange the equation, and we can get it and this suggests that D must divide 63, and then the positive divisor of 63, they are D has 1, 3, and 7, 9, this one. And now let's test is possible D here. Like for example, if case D equals 1, okay, and text here, so this is not a solution. And also for case D equals 3, and also no solution. For D equals 7, also no solution. And also we test later here, also no solution. And for the case here, we have so they are already here. And however, the 3, 1 this pair and 1, 3 they can't be used later, so they're all valid. And it gives the pair of the last 4. And then let's verify all of them. Okay, I read the part here. and then verify our answer, and then we have and the answer is 2. First, we can notice that here 1 is 5. That is because it is equals to 7, and this with a remainder of 1. And we also plus the 9 from the left side to the right side here. Okay, and both of it we know. It is 1. Okay, since this is because red and the 4 here. And we can, according to the property, that we know here when the number is 9, it is the negative 1. And so we can write it here. The answer is here. First, we have to factorize 400. I'm sorry, here. And then I simplified 7. That is because here, this equation. And we know here we have a second one that is 2. And we have right here. And then we have to find this one. We can use the theorem. And then rewrite it. Sorry. Here, and also simplified another number here. for now, and we need a number x, such as and then try to find all of the numerate. We can use letter K to use it in the both side. I'm sorry. Here. So, K. We can substitute back into the x equation before, and then we have and now the smallest non-negative remainder for the 400, that is here. So this is the answer. Okay, first we know for any A in the prime P, we have, and when here the mod is P, and this time the A is not divisible by P. So now we want to find this one, and by 5. Also, we can talk about it in different cases. For example, case 1, if in here, and for case 2, right? And also in case 3, case 4, and case 5. That is from 1 to 4. And then we can count the number n in the range of for which, right, and the number of the divisible by 5 in this range, that is, and the total number. So the number is minimize here. And finally, they want us to calculate for the past probability, and the probability P for it, that is so the answer is okay. Since PQR are primes and we know the equation that